Hey guys, I'm continuing straight on from the previous video. Our aim now is to find the centroidal distance x, by dash, and iy dash. So I've redrawn our problem and I've drawn some centroidal axes in. Straight up, xc, the x distance to the centroid, is by on a. So we found by in the previous video to be a squared h on 6. So this is a squared h on 6 times by the reciprocal of the area. So the area is ah on 2, so 2 on ah. If we were to simplify this, we would find that it would be 1/3 a. So that is the distance to the centroid, is 1/3 the distance of a. So the distance from here to here, xc, equals 1/3 a. Okay, so we can then find by dash, which is 0. So the first moment of area from our centroidal axis is always 0, just like bx dash was 0. And the next thing we need to find is iy dash, which is equal to x dash squared dA. So we now need to come up with a function for x dash. From the previous video, we know that cx equals h minus hx on a. So that was the function for a strip. So if we had a strip here, dx thick, the height of this is cx, which is the function there. So what we need to do is we need to relate the reference axis to the centroidal axis. So we're going to say that x equals xc plus x dash. So in other words, x equals xc, so that distance there, plus or minus the distance x dash, okay? And this ranges for x dash between 2/3 a and minus 1/3 a. So for example, if we subbed in minus 1/3 a for x dash, we know that xc is 1/3 a, so we would get x equals 0, which takes us here. If we did for 2/3 a, so x dash would be 2/3 a plus xc, which is 1/3 a, would give us the full length a, which is now there. So that what I've done is I've rewritten x in relation to the centroidal axis, so the reference axis in relation to the centroidal axis. So all we're going to do is substitute in for x into this formula here, and then it'll give us a function of x dash. So cx dash will equal h minus h on a, x, and x is xc plus x dash, which we can simplify to h minus h on a. xc we know is 1/3 a plus x dash. So there is now our function cx dash, and that ranges between those values over there. So if we now wanted to find ix dash, that's the integral over a of x dash squared dA, which is equal to x dash squared. dA is the area of this little strip, so it's cx dash, which is what we found here. So this would be outside of h minus h on a, open brackets, 1/3 of a plus x dash. This is by dx, so this is now essentially dA by x dash squared, and the area is going to be between this range here, so minus 1/3 a, 2/3 a. So simplifying this, we would have, I'm just going to do dot and dot for the integral, it's the same thing, just to make it a little bit easier. We would have x dash squared outside of h minus h on 3 minus hx dash on a. Simplifying this further, we would have x dash squared outside of 2h on 3 minus hx dash on a. simplifying this again, we would take out an h, have between x dash squared 2/3 minus x dash on a. This would then become, if we were to integrate this, h outside of 2 x dash cubed on 9 minus x dash to the power of 4 on 4a between 2/3 a minus 1/3 a. Just to save a bit of time, guys, you can go ahead and work this out. We actually did for something very similar already for I x dash, so I'm just going to give you the answer. It's ha cubed on 36. So that is for I x dash. Okay, guys, that completes everything you need to find. We've now found absolutely everything for this problem. And yeah, guys, I hope that clears up and is good, and hope it helps. Thanks, guys.